Good evening everyone, my name is Vaishnavi. I am from EC department and C section. Now we will discuss about GINA diode characteristics. First we will discuss introduction to GINA diode. GINA diode are specialized semiconductor devices designed to operate in the reverse breakdown region. They are commonly used for voltage regulation and reference applications. Their unique ability to maintain a constant voltage across their terminals makes them essential in electrical circuits. Construction and structure. GINA diodes are made using heavily doped PN junction to achieve a low breakdown voltage. The heavy doping result in a narrow depletion region, enabling breakdown at a specific voltage. The physical structure resembles a standard diode but with advanced doping techniques for precious characteristics. Forward bias characteristics on GINA diode. When forward bias, a GINA diode behaves like a regular diode conducting current after the threshold voltage. The forward voltage drop is typically around 0.7 volts for silicon GINA diodes. In forward bias, the GINA diodes characteristics are similarly to standard diodes with a low voltage drop. And reverse bias characteristics on GINA diode characteristics. In reverse bias, the GINA diode remains non-conductive until the breakdown voltage is reached. Once the breakdown voltage is exceeded, it conducts current in the reverse direction while maintaining a nearby constant voltage. This behavior is utilized in voltage regulation circuits for maintaining stable voltage levels. Next, GINA breakdown mechanism. GINA breakdown occurs due to quantum mechanical turning across a heavily doped junction. It typically happens at lower voltage below 5 volts and is a reversible process. This mechanism allows the diode to sustain a stable voltage during breakdown without damage if current is limited. Next, we will discuss avalanche breakdown mechanism. Avalanche breakdown occurs at higher voltage and involves carrier multiplication due to impact ionization. It is predominant in GINA diodes with breakdown voltage above approximately 5 volts. Unlike GINA breakdown, avalanche breakdown can be reconstructed if current is not properly limited. Next, we will discuss GINA voltage. GINA voltage is the precious reverse voltage at which the diode begins to conduct in the breakdown region. It is a critical parameter specified during diode manufacturing to match circuit requirement. Typically, GINA voltage range from 2 volts to 200 volts depending on application needs. GINA diode current voltage VI characteristics. The VI curve shows a sharp decline in voltage once the breakdown voltage is reached with increasing current. In the breakdown region, the voltage remains nearly constant despite change in current. The curve demonstrates the diode's ability to regulate voltage over a range of currents. Power dissipation and current limits of GINA diode. GINA diodes have maximum power ratings typically ranging from a few milliwatts to several watts. Proper current limiting resistors must be used to prevent damage during operations. Exceeding power rating can cause thermal runaway and parameter failure of the diode. And we will discuss temperature depends of GINA voltage. The GINA voltage varies with temperature usually by about 2 to 3 milliwatts degree for silicon devices. This temperature coefficient affects the accuracy of voltage regulation at different temperatures. Designers often select GINA diodes with low temperature coefficient for precious applications. And we will discuss applications of GINA diodes. GINA diodes are primarily used for voltage regulation in power supplies and signal processing circuits. They serve as voltage reference in analog to digital converts and biasing circuits. GINA diodes are also used in waveform clipper and limiter circuit to prevent voltage overshoot. And what are advantages of GINA diode? Now we will discuss. Advantages of GINA diode. They provide stable and precious voltage regulation over a wide range of currents. They are simple to implement and cost efficient for many applications. Their fast response time makes the suitable for resistant voltage suppression. And limitation and considerations. GINA diodes have a limited voltage range and power dissipation capacity. Their performance can be affected by temperature variation and aging. Proper circuit design is essential to ensure they operate within their specified parameters. Section criteria for GINA diodes. The decided breakdown voltage and power deception are primary factors in section. The temperature coefficient should be considered for precious voltage regulation. The maximum operating current and voltage tolerance and also critical parameters. And finally, we will discuss conclusion for the GINA diode characteristics. GINA diodes are virtual components for voltage regulation and reference applications. Understanding their unique characteristics help is designing reliable electrical circuits. Proper selection and circuit design ensure optimally performance and longevity of GINA diode. Thanks for this opportunity.